Morning, my name is Rich Weir. I'm the Carnivore Conservation Specialist with the Conservation Science section of the province of BC. This morning I'm going to do a short presentation on some recent work that we've done to better understand the populations of fishers in BC. Now, I'm going to start by just admitting that I love fishers. I think they're the most amazing animal on the planet. Not only are they beautiful, charismatic, fast, and powerful predators, they have this amazing, soft, luxurious fur and this surprisingly wonderful aroma that's the delightful smell of musky roses. Not only do I love fishers, I love the idea of fishers. Fishers really are ninjas of the forest. They're cloaked in black, they move swiftly and silently through the forest, and they come and go without the faintest sound. They really are just this incredibly secretive animal. And they're so stealthy. I'm not sure how many people at the forum have seen a live fisher in the wild, but if you have, count yourself extremely lucky. Although you may not get to see fishers very often, these ninjas strike fear into the hearts of animals like snowshoe hares, squirrels, grouse, and even the venerable porcupine. How can you not be enthralled with an animal that has the immense speed, power, and agility to be able to repeatedly zip in, bite the head of a porcupine, and then zip back out before the porcupine has a chance to swing its tail around and land a blow? It's absolutely amazing. It fascinates me to no end. Unfortunately, it seems that fisher populations in BC aren't doing very well these days. The ninjas of the forest seem to be having a harder time. And I want to tell you their story. So I first started working on fishers back in 1990. That's me on the left there with my mullet. I didn't know much about anything. Some people say I still don't. But I was young and eager, and I just signed up to do graduate work on fishers. Back in 1990, we didn't have much scientific data on fishers in BC. We knew they were trapped through northern and central BC, but the harvests were declining back then, and nobody had a really good sense of why. So along I came to hopefully learn more about what was happening with fishers, and I really just wanted to understand what made these animals tick. I've been really fortunate to have spent the better part of the last 30 years of my career as a wildlife biologist working on fishers in various spots throughout the province. I've had the incredible good fortune to have the opportunity to get up close and personal with fishers when we've captured and handled them. I've been blessed to spend a lot of time just being with fishers in the forest that they occupy. I always think they're whispering their secrets to me. And we kind of learned as much as we can from fishers while we're out there, so we can get that better understanding of how they work. One of the things that we've learned over the years is that fishers don't do very well where there's deep, soft snow. You know how when you go out into the forest on a warm afternoon in late March and the snow is really crappy, doesn't support your body weight, and you sink up to your crotch? As post-holing makes walking through the forest pretty difficult. Well, fishers kind of have the same problem. Unlike animals like snowshoe hares and lynx that have big snowshoe-like feet, the body weight of a fisher is large relative to their feet size, and they have a really hard time moving through deep, soft snow because they sink so much. Now, you might not think this is such a big deal, so they have a hard time moving around in the snow. It actually has some pretty big implications for their populations in BC. So I've always wondered if fishers in BC were just one big happy family, with animals moving around the population freely. It's actually an important thing to know if they do that, if we want fishers to keep doing their thing throughout their range. You can imagine that fishers, being a species that's harvested by trappers and sensitive to habitat change, need to have large connected populations so that if fishers wink out in one area, animals can move in from nearby areas. If we look at where fishers occur in BC, however, you'll notice that they're kind of limited to the low elevation forests of central BC and northeastern BC. Separating these two chunks are the Rocky, Skeena, and Omnika mountain ranges. Lovely areas with towering peaks, great for hiking, wonderful mountain vistas, and snow. So much snow in the wintertime. It's great for backcountry skiing and sledding, it's kind of crappy if you're a fisher. And so as a result of this deep, soft snow in these areas, fishers will find it harder and harder to get from one side of the mountain range to the other. So from one blob to the next. This barrier means that it's difficult for dispersing animals in one side of the Rockies to make it through to the other side. So, they can't easily go from Fort St. John over to Mackenzie because there's a big mountain range with lots of deep, soft snow. And likewise, fishers from the central interior, they have a hard time making it over to the Rockies side, the other side of the Rockies, because there's this big barrier in the way. And we actually collected a lot of genetic information on fishers from throughout BC, and we actually found that this ability to move between the populations, or between those two blobs, is about one fisher per year going either way. And this ultimately means that few fishers are able to make it through the mountain ranges. And this rate of one fisher per year is really low. If this happens over a long period of time, the genetic makeup of the fishers on either side of the mountain range starts to slowly change and become different from each other. This is partly because the natural selection is different on the other side, so different environments, but also because through a thing called genetic drift. So what we find is that the populations slowly start to change and become different. Now, I kind of like to think of this as like two vehicles driving down a highway with a split in the road. One road leads to a paved, windy coastal road where sports cars needed, where the other's going to a soft dirt road leading off to some boggy forested area where mud tires are good. You end up in different places, needing different types of vehicle, depending on where the road takes you. So it's kind of like how the populations, or how the fishers might have split between the central interior and the boreal. And when we actually looked at all the genetic makeup of the two areas, we found that fishers in the central interior drifted quite a bit from their cousins in the boreal forest because of the effect of this mountain barrier and the low amount of dispersal or connectivity between them. And the fishers in the central interior are now their own distinct population. Essentially, these two populations, the boreal and the Columbian, are independently of each other. So the fishers in the central interior, we say, is the Columbian population, and those in the northeast and northern part of the province are the boreal population. So the genetic evidence suggests that we don't have one big happy family of fishers in BC after all. It looks like there's been a divorce, with the Rocky Mountains breaking up the marriage. And much like a divorce, the two populations can no longer rely on each other for support, and the two sides really must forge their own paths independent of each other. So divorces are often not equal, and this is another case where divorce, where one side might be doing better than the other. This is important for us to know. As separated populations, they can't really rely on each other for support. Fishers that live in the boreal population aren't going to help out their cousins in the Columbian population if things get rough. Now, as I mentioned at the start, we spent quite a bit of time over the past 30 years learning about fishers by following radio-tagged animals in various parts of the province. And one of the things that we can learn from these animals, if you follow enough of them for long enough periods of time, is how well they survive from year to year and how many babies they produce each year. And we've been fortunate to be able to follow about 100 fishers in 5 or 6 different study areas and have them whisper the secrets of their lives to us. And this is some of what they told us. Much like you and me, fishers just want a home to live in, enough food to keep their bellies full, and a chance to raise a family, and a life free from harm. Fishers, as you'd expect from being ninjas of the forest, lead a pretty rough and tumble lifestyle. They grow up fast, live hard, and die young. It kind of sounds like a title from a cheesy 80s rock ballad, but they really are like that. By the time a fisher babies reach 8 or 9 months of age, Mom kicks them out of their home range, and they must strike out on their own to find a territory with enough food to support them, habitats to keep them protected from predators and harsh temperatures, and places to raise their babies safely. We've learned that achieving this is hard, and there are many perils along the way, and life is pretty different depending on which side of the mountains you live on. So in both populations, we found that fishers, they die from a number of different ways. About a third of our deaths of radio-tagged fishers were caused by humans, largely through trapping. Another third were killed by other carnivores, wolverines, lynx, and other fishers. And the final third died from accidents, starvation, or undetermined causes. Interestingly, this fisher that's on the upper left here died when the cottonwood she was in and raiding a goldeneye nest toppled over. That's some really bad luck. However, when we looked at the year-to-year survival of fishers, we found that about 75% of fishers survived from 1 year to the next, and this didn't seem to matter which side of the mountains you came from. So which side of the family? There were, however, some differences between youngsters and older adults. So, a long time ago, when I was young and not so smart, I confess that I didn't know what I was doing, and I made some stupid decisions, like the mullet and the mustache there. Now that I'm older and wiser, I like to think I don't get into as much trouble as I used to, and I think the same thing happens with fishers. The young and experienced ones don't know how to avoid dying as good as adults. And we certainly observed this in the fishers that we had radio tagged over the years. If we started a year with 10 subadult fishers, only about 64% of them survived to the next year. So, they lost 3.5 of their cohort in the year. The older and wiser adults, however, had survival rates that were around 80%. So, only 2 died. And so once you got to be an adult fisher, living was pretty good. You were doing fine. So what we found was there was actually a significant difference between the survival rates of adults and subadults, and this isn't too surprising. The real difference between the two populations, however, came to light when we looked at how many babies were being produced by female fishers. So female fishers don't give birth until they're at least 2 years old, and they have a fairly short reproductive lifespan of maybe 4 or 5 years. So they might live to 6 or 7. And we found that fishers in the boreal forest had larger litters way more frequently than females in the Colombian population. It's not hard to imagine that having larger litters more often is going to translate to more kits being produced in the female's lifetime. In fact, female fishers in the Colombian population only produce, on average, about 0.8 of a kit per adult female per year, whereas in the boreal population, this number is more than twice as high, at 2.1 kits per adult female per year. So there's a pretty significant difference between the two populations. But what does it mean? There's clearly this difference in reproductive rate. But does it mean the populations are doing better than the other? Is one side of the divorce doing better than the other side? So it kind of makes sense that the trend of a population, whether it's increasing or decreasing, or even its ability to respond when things are good, is related to the number of animals being born in the population minus the number of animals that die each year. So I like to think of populations as very much like a bucket of water with some holes in it. This might seem a bit weird, but stay with me for a second. I think it helps us understand the differences between the two populations in BC. We can think of it like this. The number of animals that are born each year is the volume of water that's poured into the bucket. The number of animals that die each year is the water flowing out of the holes in the bucket. And if more water is poured into the bucket each year than drained each year, the water level in the bucket rises. And if the population is doing better, and if more water drains out of the bucket than is poured in, the water level will fall. So the population trend is whether the bucket is filling or draining with water. For the two populations of fishers in BC, they both have the same number of holes in their bucket, more or less. And they're losing about 25% of their animals per year, of the fishers in the population. But less than half the water flows into the Colombian bucket than into the boreal bucket, because the difference in reproductive rates. So as a result, the bucket in the boreal forest fills up, whereas the bucket in the Colombian population is slowly draining. So to go back to the divorce scenario from earlier, it seems that the portion of the family that gets to live in the boreal forests are living the high life with more money, more resources, and a bucket of water that's slowly filling up. Whereas the other side of the family that lives in the central interior is having a much harder time, and their bucket is slowly draining. And there's literally no child support coming to the fishers in the Colombian population, if you want to think of it that way. So this is pretty concerning stuff. The Colombian population is having a really hard time filling its bucket and is on a concerning downward trajectory. So the fishers in the Colombian population, they're in a bit of a pickle. They've got the short end of the divorce. They aren't doing as well as fishers on the other side of the Rockies. Not only do they seem to have a hard time making a go of it, where they live has changed quite a bit over the past 40 years, and this is making it harder and harder for them to find enough forest to live in because of logging and wildfires and a whole lot of things are happening within their population. So what's going to become of the population? How are these fishers going to survive and reproduce? What is needed for this population to turn itself around? It's clear they need some help. What do they need? Are these insurmountable obstacles, even for a ninja? We need to know what's needed, needs to be done to turn the ship around for our little friends. We need to figure out a way to fill the bucket back up, as it were. But did this involve, I don't know, plugging the holes in the bucket by reducing the number of fishers dying in the population? Or do we need to help them open the tap and have more kits so that the bucket would fill up faster and offset these losses? But to figure out what that answer was, we took data about the birth and death rates that I showed a bit earlier and projected forward what the population would look like in 100 years. We first wanted to know what the state of the population would be if the rates of birth and death stayed the same, like they have over the past 20 years. The results were pretty grim. Our models using survival and reproductive rates that have been measured specifically in the population predicted that the population would be extinct in just under 11 years. 11 years. That is not much time. If a child was in grade 1 this year, our models predict that the Colombian population of fishers would be extinct before they graduate from high school if we keep on the course we're currently on. As someone who loves fishers, this terrifies me. I hope it kind of terrifies you too. Because something needs to change. So we got to thinking about how we could make things better for this population of fishers, because clearly we have to do something. We can't just keep doing what we've been doing for the past 20 years, because these guys are going to be gone in 11 years. As most of you likely know, fishers are a fur bearer, and up until 2021, fishers in the Colombian population could be trapped for their pelts, which are worth about $35 each. However, most fishers that are harvested by trappers are not intentionally trapped. They're actually caught incidentally in traps set for other fur bearers. About half these fishers are caught in traps set for the much smaller martens and minks, with the other half being caught in traps set for lynx, bobcat, wolverines, and also in snares set for a variety of species, including coyotes and wolves. So the vast majority of the death of fishers, human-caused death of fishers, comes from incidental harvest in these traps. About half the bycatch are in trap set for the smaller martens and minks, as I mentioned. And as part of another project, we worked with trappers to figure out a way to keep fishers out of traps. These traps set specifically for martens and minks. So we thought we would see what it would look like if we were able to eliminate the incidental harvest from these types of traps set for martens and minks. Surely that can make a difference. Apparently not. Even if we eliminate bycatch in traps set for martens and minks, the population is still predicted to be extirpated in less than 17 years. So even if we're reducing half the incidental mortality, it's only buying us 6 years. And this is concerning as well. It looks like even just a little bit of incidental harvest is driving this population towards extinction. So we looked at what would happen if we removed all incidental harvest. So if we were able to magically have zero incidental harvest, and the population still went extinct. But at least 37 years, this will give us a bit of time to get things right. And this is very concerning. Clearly more than just eliminating incidental harvest is needed for this population to have a chance to recover. So in addition to scaring the pants off us as to how dire the predictions were, the analysis that Rory Fogarty, the fellow who did the research, helped us understand what needs to happen for the decline to turn around. So to have a population with a positive growth rate, so that's one that's recovering, we need to tweak a few things. Well, first, we got to stop killing them. We've got that figured out already. We also have to just increase normal female survival, not above by 10%, above just normal mortality without any human-caused mortality. And third, we need to increase the proportion of adult females producing litter. So we need to bump up, increase the flow of water into the bucket, as it were. The first one should be easy to do immediately, by regulation of the Wildlife Act, which is the authority of the Ministry of Forests. The other two are long-term fixes that involve significant improvements to habitats that fishers need to survive and reproduce. It's pretty clear that the Colombian population of fishers needs to have holes in its buckets patched over. It simply cannot sustain continued incidental harvest. Trapping season starts soon, November 1st, but as it currently sits, there are no changes to trapping regulations to reduce bycatch, which for me personally is the most worrying part of the whole thing. We know that we need to reduce incidental harvest, and yet there are no planned regulatory changes to achieve that. If we don't get the incidental harvest limited, there's no way this population is going to persist. We need to put those band-aids and more back on that bucket. The longer we allow this incidental harvest to continue, the deeper the hole we're digging for ourselves, and the harder it is going to be to recover this unique population of ninjas of the forest. So there you have it. Turns out I was wrong at the start. Fishers in BC are not one big happy family. It looks like the Rocky Mountains got in the way and cleaved the family into two. The boreal side of the family has a bucket that is full of water, but the Colombian population side has a bucket that is rapidly draining. We have a pretty good idea how to fill some of the holes and slow the flow, but we're still standing watching the water pour out as we run out of time to have any water left in that bucket at all. So that's where I'll end. Thank you for your time for listening. There's much work remaining to be done to recover the Colombian population. I think that's the subject of the next few sessions of this forum. But if you would like to contact me, get more details about the research that's been done, feel free to drop me a line, and I'll end with the publications on which this talk was based. Thank you for your time.